Hello everyone, my name is Alhadi Alsaffar. I'm from Cardiff University. Today I will be presenting our paper Asset-Centric Knowledge Sharing for Permitting and Compliance with Digital Technologies. The main idea of this work is that permitting and compliance are not only technical or regulatory check, they are also depend on an effective knowledge sharing between multiple stakeholders. When compliance knowledge is fragmented, it becomes difficult for stakeholders to trace it and validate it or use it. To begin, I want to explain why this topic matters now. Permitting and compliance involve many stakeholders, such as designers, engineers, contractors, regulatory authorities. These groups need to exchange regulation, design information, inspection data, and professional judgment, especially the professional judgment. However, this information is often fragmented, where project data can be trapped in disconnected teams. This reduces traceability and can lead to compliance decisions that don't match across teams. At the same time, the industry is moving through a digital transformation while growing use of BIM and digital twin. Because of this, having compliance information that can be easily checked and shared is becoming an operational requirement, not just future goal. So the core challenge is that compliance evidence is often hard to share, hard to check, and hard to use across stakeholders. The existing research already shows important progress where BIM, group cooperation, digital twin, group asset management, blockchain support, trust, and traceable records, and construction knowledge management continue to develop. However, two main questions remain. We still have limited evidence on how knowledge sharing and digital technologies work together in permitting and compliance, and we still lack of structured understanding of how these concepts relate to each other. This creates research gap. So the next slide will explain how the research gap addressed. To address this gap, the study looks at how people currently share knowledge and what digital tools they use in permitting and compliance. It focuses on it focuses on two connected research questions. The first one explores what is happening in practice, and the second one looks on how the main idea relate to each other. Together, these questions lead to two contributions, real-world funding and structure map for the presentation. So the methodology about is the study used a mixed method survey design. The survey had 25 questions where we collected 110 valid responses, and 30 of these responses also provided open-ended comments. The study uses both quantitative and qualitative analysis. The quantitative analysis identified the main pattern, while the qualitative analysis provided additional insight. The sample was highly relevant with experienced professionals from permitting, compliance, engineering, project management, regulation, and digital rules. This slide shows the conceptual lean used in the paper, the SECI knowledge creation model, which is useful because permitting and compliance rely on both explicit and tacit knowledge. Explicit knowledge includes documents, reports, BIM models, regulation, and formal evidence. The tacit knowledge includes professional judgment, experience, and how requirements are understood in practice. In this study, BIM helped make design intent explicit and shareable. Digital twin can support life cycle learning and reuse. Blockchain enable trust and traceable exchange through immutable records. AI and machine learning can support knowledge extraction and strengthen knowledge management system. So this model help explain why compliance is not only about storing information, it's also about how knowledge is converted to shared and reused across stakeholders. Now I move to the fundings for research question one, part one. The first result is that standard tools still dominate knowledge sharing. Email and collaboration platforms are each used by around 70% of response. The rated effectiveness of current knowledge sharing practice only moderate. As shown here, still unrealistic potential. The most important funding is in this part is different between internal and external sharing, where as you can see, the internal sharing is much more frequent than the external sharing. This matters because permitting requires coordination across an organization. If the knowledge stays inside the organization, permit workflow should it will go slow. The second part of research question 1 looks at the digital technology adoption and barriers. The results show an even digital picture. BIM is the most widely adopted. AI is also high, while blockchain, digital twin, and Internet of Things are still emerging. The biggest barriers are communication between departments, lack of technology, and the absence of formal knowledge sharing process. So the issue is not only technical, it's also organizational. The key message is that digital technologies are available, but the knowledge sharing environment is not yet fully mature. This slide explains how research question 2 was addressed. To answer research question 2, the survey evidence and qualitative were synthesized using concept mapping. The process began by defining the domain as assets management, compliance, and permitting. The key concepts were identified, including digital technologies, knowledge management, compliance and assurance process, and strategic barriers. These concepts were then organized into hierarchy, and cross-link were added to show how they relate to each other. The important point is that the map empirically grounded. It's not just a theoretical diagram. The concept hierarchy and cross-link are all come directly from the survey finding. This slide shows the complete refined hierarchical conceptual map. The previous slide gave the simplified workflow. As you can see in the diagram, solid arrows show the hierarchy and dashes thread cross-link. As you can see here, where's the BIM support, the digital twin as the foundational support for it. The map brings together the main areas of the study: digital technologies, knowledge management, compliance and assurance process, strategic barriers, and improved assets management compliance outcome. So this slide, so what? This is the so what slide. The key cross-links show how the technologies work together. BIM, underpin, digital twin, blockchain support, the trust pyramid certification, AI strengthen knowledge management, and strategic barriers limit the digital adoption. For researchers, the map provides a structured, testable framework. For industrial, it provides a structured way to understand the relationship between technologies, knowledge management, and compliance, and the organizational barriers. Overall, the refined conceptual map transforms survey evidence into both the research framework and maybe practical roadmap for the industry. This slide summarizes the contribution of the study. It provides a combined empirical account of knowledge sharing practice and enable digital technology and permitting and compliance checking. To also develop a refined hierarchical conceptual map linking technologies, knowledge process, assurance practice, and implementation condition. The framework also distinguishes the role of technologies. BIM support the design stage, digital twin support the lifecycle monitoring, blockchain support trust pyramid certification, and AI enhance the knowledge management system. This slide translates the funding into practical implication. The main message is that technology must be matched with people and process skills, and training are needed to strengthen knowledge management capabilities. Standardized system can reduce fragmentation. New technology should be used strategically, and leadership and culture are essential for sustainable digital adoption. So a successful digital adoption requires technology, people, process, and governance. To conclude, there are three main takeaways. First, construction knowledge is still fragmented, practically across organization. Second, BIM and AI are well established, while blockchain and digital are still emerging. Finally, the technology alone is not enough. Progress also depends on communication, skills, process, and organization support. Overall, the refined conceptual map provides a structured pathway for digital permit certification and compliance checking. For future work, we will move from the conceptual map to test workflow. First, we will turn the main concept into prototype solution like practical workflow or digital tools. Then we will test the solution in real project to see how well the framework works. After that, we will study specific relationship ship in more details, such as how knowledge sharing change with project size or team structure. The overall goal is to understand how knowledge sharing can be support, permitting, and compliance. So thank you very much for your attention.